Electroluminescent wire is a thin copper wire coated in a phosphor which glows when an alternating current is applied to it. It can be used in a wide variety of applications: vehicle and/or structure decoration, safety and emergency lighting, toys, clothing, etc. Much as rope light or Christmas lights are often used. Unlike these types of strand lights, EL wire is not a series of points, but produces a 360-degree unbroken line of visible light. Its thin diameter makes it flexible and ideal for use in a variety of applications such as clothing or costumes. Structure: EL wire's construction consists of 5 major components. First is a solid copper wire core, coated with phosphor. A very fine wire or pair of wires is spiral wound around the phosphor-coated copper core, and then the outer conductive coating is evaporated on. This fine wire is electrically isolated from the copper core. Surrounding this sandwich of copper core, phosphor, and fine copper wire is a clear PVC sleeve. Finally, surrounding this thin, clear PVC sleeve is another clear, colored translucent, or fluorescent PVC sleeve. An alternating current electric potential of approximately 90 to 120 volts at about 1000 Hz is applied between the copper core wire and the fine wire that surrounds the copper core. The wire can be modeled as a coaxial capacitor with about 1 mF of capacitance per foot, and the rapid charging and discharging of this capacitor excites the phosphor to emit light. The colors of light that can be produced efficiently by phosphors are limited, so many types of wire use an additional fluorescent organic dye in the clear PVC sleeve to produce the final result. These organic dyes produce colors like red and purple when excited by the blue-green light of the core. A resonant oscillator is typically used to generate the high-voltage drive signal. Because of the capacitance load of the EL wire, using an inductive transformer makes the driver a tuned LC oscillator, and therefore very efficient. The efficiency of EL wire is very high, and thus a few hundred feet of EL wire can be driven by AA batteries for several hours. In recent years, the LC circuit has been replaced for some applications with a single-chip switched capacitor inverter IC such as the Supertex HV850. This can run 1 foot of angel hair wire at high efficiency, suitable for solar lanterns and other safety applications. The other advantage of these chips is that the control signals can be derived from a microcontroller, so brightness and color can vary depending on battery state or ambient temperature. EL wire, in common with other types of EL device, does have limitations. At high frequency it dissipates a lot of heat, and that can lead to breakdown and loss of brightness over time. There is also a voltage limit. The typical wire breaks down at around 180 VPP, so if using an unregulated transformer, back-to-back Zenas and series current limiting resistor is essential. In addition, EL sheet and wire can sometimes be used as a touch sensor, as compressing the capacitor will change its value. Sequencers: EL wire sequencers can flash electroluminescent wire, or EL wire, in sequential patterns. EL wire requires a low-power, high-frequency driver to cause the wire to illuminate. Most EL wire drivers simply light up one strand of EL wire in a constant on mode, and some drivers may additionally have a blink or strobe mode. A sound-activated driver will light EL wire in synchronization to music, speech, or other ambient sound, but an EL wire sequencer will allow multiple lengths of EL wire to be flashed in a desired sequence. The lengths of EL wire can all be the same color, or a variety of colors. The images above show a sign that displays a telephone number, where the numbers were formed using different colors of EL wire. There are 10 numbers, each of which is connected to a different channel of the EL wire sequencer. The sequencer pictured is the CAT 092 to 10 channel sequencer developed by Cool Neon, a distributor of EL wire. Like EL wire drivers, sequencers are rated to drive a range or specific length of EL wire. For example, using a sequencer rated for 1.5 to 14 meters, if less than 1.5 m is used, there is a risk of burning out the sequencer, and if more than 14 m is used, the EL wire will not light as brightly as intended. There are commercially available EL wire sequencers capable of lighting 3, 4, 5, or 10 lengths of EL wire. There are professional and experimental sequencers with many more than 10 channels, but for most applications, 10 channels is enough. Sequencers usually have options for changing the speed, reversing, changing the order of the sequence, and sometimes, to change whether the first wires remain lit or go off as the rest of the wires in the sequence are lit. wire sequencers tend to be smaller than a pack of cigarettes and most are powered by batteries. This versatility lends to the sequencer's use at nighttime events where mains electricity is not available. Applications by arranging each strand of EL wire into a shape slightly different from the previous one, it is possible to create animations using EL wire sequencers. EL wire sequencers are also used for costumes and have been used to create animations on various items such as kimonos, purses, neckties, and motorcycle tanks. They are increasingly popular among artists, dancers, maker culture, and similar creative communities, such as exhibited in the annual Burning Man Alt Culture Festival. References: 5,753,381 U.S. patent, electroluminescent filament. External links: How Electroluminescent Wire Works, by Joanna Burgess. How Stuff Works.